I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss inverse functions with a grade 8 student. Hi Abhinav, how are you doing?
I'm good.
So today, what do you want to do?
Inverse functions.
Inverse functions, right? So you are in grade 8 and you are doing grade 10 functions, right? That's good.
Yes.
So which functions have you done so far?
I studied about quadratic and linear functions.
Perfect. So we'll see how to find inverse of these functions. Let me share with you one of my documents on inverse function, and
Okay.
from there we'll pick it up. Okay, so can you see my screen?
Yeah.
Perfect. So we'll first talk about what are relations, and then we'll look into what is a function, and then all the functions, do they have an inverse as a function or not? So this is the first question which we are going to answer. I would like you to read what is written about the relations right there on the screen. Can you please read it?
Relations. Relation is a rule that connects inputs to the outputs. Input is taken as an independent variable. Output depends on the input and is considered dependent variable. Set of input or domain of the relation. Set of outputs is a range of the function.
Perfect. So it is very clearly defined. Is there any ambiguity in the definition? Do you understand everything?
Yeah.
Okay. So these are the inputs shown here. So these inputs, they form domain for a function, right? They are independent variables which represent the domain of the function, correct?
Yeah.
So inputs are considered independent and they are domain of the relations. Is that clear?
Yeah.
And this output is the range, the y value, and it is dependent on the input. In between, this is the function. When we say a function, then we basically mean this part, a rule. Do you understand? That rule is the function which we are talking about, which converts the input as per the rule and gives you the output, and that is what we call a function. Now, I have a couple of functions here. The first one is just telling you overall that input, when processed by a rule, gives you an output. Now, here is the second input, and my function is my mother. Now, you understand that in this world, all living things have a mother, right?
Yeah.
So everything, living thing on this earth is related with mothers, right? So we can have two sets here. What we are saying here is my mother. When I say my mother, that means we are defining a relation between the two, right? This is a relation. Everything is connected with a relation. And the relation here is my mother. So let us say if I write A here and the mother of A is capital A, let us see, and we write B here. B is the mother of capital B. But there is a possibility that if I write X here, then X mother is also B, correct?
Yeah.
So because a mother can have more than one child. Now, what kind of relation is this? We call this many to one relation.
Okay.
Now we are actually looking into inverse function, right? Now, if I say, if the mother says now, if I flip it, that is to say, when we go from output towards the function and do we get the input back? That is what we are interested in figuring out when we talk about inverse of a function. You get the idea?
Yeah.
Now, mother A says, my child. We know that the child of mother A is small a, correct?
Yeah.
But if mother B says my child, in that case, we really don't know which child mother is talking about, the elder or younger, B or X, correct?
Yeah.
So that is an ambiguity. Is this a function? No. This inverse is not a function, correct?
Yeah.
So we have many relations in which inverse may not be a function. Well, going from one set to other could be a function coming back or returning, or the inverse may not be a function. This is very important thing to understand. Is that clear to you?
Yeah.
You talked about two things, and that is you were saying about linear and quadratic functions, correct? Let
Yeah.
us take both the examples to understand, and then we'll move forward, because I want your basics or the foundation to be absolutely perfect. So when you say a linear function, it means what? If I graph, I'll get a straight line, correct?
Yeah.
Now, on this particular graph, the x values are the independent values. They contribute towards the domain of the function. The y values are the dependent values, which give you the range. And let us say, if I have an input x1, in that case, we know for this input, the output is y1, correct?
Yeah.
So it is a function. Now, let us see the reverse of it. If I plug in y1 here, then what do I get? I get to this point and I get to x1. You see that?
Yeah.
And it is unique, correct?
Yeah.
So it is unique. So what we see here is this kind of a relation is one-to-one relation. And in this case, the reverse of the relation is also a function because it is one-to-one, correct?
Yeah.
So we say inverse is also a function. Correct. At present, we'll define the word inverse later. You can say reverse operation, right? So we are doing just the reverse operation to look into it. So we are just looking into reverse operation. Let me write down reverse operation. I'll teach you, explain you what reverse operation really means. But let me get to the parabola also. So if I draw a parabola, let us say this is a quadratic function, correct?
Yeah.
Now, if I send an input x1, let's say x1 is the input, then what is the output? y1, correct?
Yeah.
But now, if I want to go reverse, for y1, what is the input? If I want to follow the reverse path, then for y1, what is the output?
There's two.
There are two, because if I draw a horizontal line, there could be this value also. You see that? So I have either x1 or I have x2. You see that? And therefore, the reverse operation is not a function, right?
Yeah.
You can visualize why it is so. Because I have that horizontal line striking the curve at 2 points, correct?
Yeah.
So we say this is called horizontal line test. So if you have a graph and if you draw a horizontal line, if it crosses more than 1 point, in that case, inverse is not a function. Clear?
Yeah.
Just as you have vertical line test for function, correct? If you draw a vertical line and if it passes through more than 1 point, then that is not a function, correct?
Yeah.
Similarly, for inverse, we are doing the reverse of it. If there is a horizontal line striking at 2 places, 2 or more than 1, I can say, then it is not an inverse. So you saw that parabola, which is graph of a quadratic equation, does not have inverse as a function, correct?
Yeah.
But what you can do is you could actually restrict this parabola, correct? We can restrict this parabola. Let me write down here restrict. How do we restrict? We can restrict the domain, for example, correct? We can say, well, it is turning from this particular point, then let x be greater than equal to 0. In that case, I am only looking at one side of it, correct? Not the other side. So now I have only one graph which I can highlight on this side. And if I look at one graph, then it passes the horizontal line test.
Yeah.
And therefore, its inverse will be a function. Is that clear to you?
Yeah.
That is the basic concept. So you have learned very good functions, linear and quadratic. One of them will have inverse as a function. The other one will not have inverse as a function. However, you can restrict the domain of your parabola from the vertex to either side and make the inverse also a function. You get this idea?
Yeah.
Perfect, perfect. Shall we move on from here?
Yeah.
Okay, now please read the definition of function.
Function. Function is a relation in which each value of independent variable corresponds to only one value of the dependent variable.
Correct.
One to many or many to many is a relation, but not a function.
Correct. One to many or many to many. Many to many examples are like teachers and students, correct? Now,
Yeah.
any student will have many teachers and every teacher is teaching so many students, correct?
Yeah.
So if a student says, my teacher, I mean, I don't know which teacher you're talking about, correct?
Yeah.
If a teacher says, my student, oh, he has to be more specific. We don't know which student. So whenever there is an ambiguity in mathematics, we do not consider that to be a correct statement, right? So that is not a function. This is our base. Is that clear to you?
Yeah.
Now, the function, as you know, can be represented so many ways. On the screen, you see how many ways we are representing the function. Or rather, let me say relation, right? Relation, all functions are relation, correct?
Yeah.
So one way to do it is in words, just as we said, my mother, my teacher. So we are relating the function with a rule, and the rule here is my teacher, correct? We can express a function in words. We can also express the function as a set of ordered pairs, just as you see, a coordinate point, right? 1, 2, 3, 4, like this shown here. In that case, we put curly brackets to signify the set. So this curly bracket here means set of. Is that clear to you?
Yeah.
And these, each points are the ordered pairs in which the values are written in the form of x comma y, where x is the independent variable corresponding to the elements in the domain, and y is the dependent variable corresponding to the elements in the range. Is that clear to you?
Yeah.
Perfect. So for this ordered pair, if I ask you, find the range of this, can you tell me the range of this ordered pair? Let me call a name A here. A set has a range of set A. Tell me, what is the range of this? How will you write it?
The range of set is 1, 2, and 5.
2, 1, and 5, correct?
Yeah.
You do not repeat the numbers, right? When you write the repeat, 2, 1, and 5. That is correct. And what is the domain of this function?
The domain is 1, 2, and 3, and 5.
Perfect. So that becomes the domain and range. You are absolutely clear about it. Now, we can also represent a relation or a function in the form of an equation, just as we have one, y square equals to x, correct?
Yeah.
Right. Now, is y square equals to x a function or not a function? Tell me.
It is a function.
No, not a function. Tell me why now. I'm saying y square equals to x. That means y is equal to what?
Square root of x.
With plus and minus sign.
Oh, yeah.
Because minus 4 square is 16, plus 4 square is also 16. So if you go back from 16, then you will either reach minus 4 or 4. You see that?
Yeah.
So if I write y square equals to x, then the inverse is, the reverse operation is basically flipping x and y. You get the idea now. What are we doing? We are making domain as the range and range as the domain. We are flipping the elements of the domain with the range, interchanging x and y. You see that? So the inverse of this operation basically means what? It means just flip it, right? We're saying x square equals to y, and that is called the inverse. You see that now?
Yeah.
We flipped x and y values, and we were x square equals to y. Now, if I say minus 4 square of that is 16, plus 4, square of that is also 16. If I go backwards from 16, I land either at minus 4 or at plus 4. Both are not the same. And therefore, it is not a function. Clear?
Yeah.
Perfect. You could do either way. Now, here is the graph for y equals to x squared. Oh, sorry, this graph is not y equals to x squared. This graph is y square equals to x. Sorry. This graph is y square equals to x, right?
Yeah.
Because now, what is happening here? For every value, no, this graph is not related. Sorry. Let's not confuse ourselves. Okay. Now, the next thing is, you could also represent a function with a graph, correct?
Yeah.
Any graph will represent a relation, but if it passes the vertical line test, then it is a function, otherwise not. Is that clear to you?
Yeah.
Correct. Well, this is not a graph of this function written here. Let's be very clear about it. Correct?
Yeah.
Correct. So, in this particular graph, we have two parabolas, square root of plus and minus we are actually writing here, right? So this is y equals to square root of x. This graph is for y equals to plus and minus square root of x. Is that clear to you?
Yeah.
So this is the inverse of a parabola x square basically, which I have drawn here. So y equals to plus minus square root of x. You can see that this is not a function, right?
Yeah.
Because it fails a vertical line test, correct?
Yeah.
Correct. Now we could also represent a function or a relation in terms of a mapping diagram as shown here, correct?
Yeah.
What type of relation is this mapping diagram? Tell me.
Many to many?
No, every one of them is actually, these two are going to 1, right? So in that case, so it is not 1 to 1. So many are going to 1. Do you see that? So more than 2, many to 1. Is it okay?
Okay. Yeah.
Many to 1 is a function. Many to 1 is a function. Okay. For example, minus 4 square and 4 square is 16. It is a function. Minus 4 square has a unique value. 4 square has a unique value. But its inverse is not a function. You get the idea?
Yeah.
Many to 1 is a function, but its inverse is not a function. Perfect?
Yeah.
Great. So this screen actually tells you how are we representing the relations. So we can represent relation in terms of words, set of ordered pairs, equations, graph, mapping diagrams. There are so many other ways. Tables, right? Which I have not mentioned here. There are so many ways, right?
Yeah.
Table of values. And many other ways, right? Graph, some other kinds of, right? But these are major. Is it clear to you?
Yeah.
From these, we can also make out visually whether it is a function or not. We can also figure out whether its inverse will be a function or not. Correct?
Yeah.
For example, if I take this one, and as you can see, we have got 2 5s right here.
Yeah.
That means if I do the inverse, there is a problem. 1 5 corresponds to 5, the other one corresponds to 1. Is that clear? So its inverse is not a function. So if you're given a set as shown here, set of ordered pairs, in that case, whether inverse is a function or not, look at the y values. Do we have duplicates?
Yeah.
If we are only considering the function, look at the x values. Do we have duplicates? You get the idea, right?
Yeah.
So that is what relations and functions relate to one another. Now here, let's get into functions first, and then we'll talk about inverse also. We are actually going in parallel, understanding both the things, right? It's like a fusion. Function, and these are the two sides of a coin, correct? Now, function, can you read this question?
Functions can be represented in many ways. Words, square of a number, table of values, set of ordered pairs,
correct,
equation,
right,
graph,
yes,
and mapping diagram.
Correct. This is the summary of what we just did. Everything clear to you, right?
Yeah.
Now, using functions, you use function notation. Normally, you will just write y equals to mx plus b, y equals to 2x plus 3, y equals to half x minus 7, whatever, right? Always y.
Yeah.
Why not name it? We can say, give a name to f of x equals f of x when we write in a function notation means independent variable is x and the dependent is f of x, correct?
Yeah.
So in that case, what really happens is when you're trying to sketch this particular graph, let me just graph any graph, right? In that case, for a value, which is x1, the y value is called f of x1, correct?
Yeah.
That is the y value. So instead of writing y, we write f of x. Now it has a name. We could say f of x, and now I can draw another graph here, right? Let's say this graph, and I call this as g of x. Do you see that?
Yeah.
I have got two different graphs. Now I can refer to it. When is g of x greater than f of x? Correct? From the graph, you can figure out.
Yeah.
When are both the functions equal? Now I can compare, communicate very properly. Exactly, correct? Because I have named them just as me and you have names. Similarly, we name functions and we call this as function notation, correct?
Yeah.
Can you please read what is given on this function notation?
Notation f of x represents the output of a function for a given set of inputs defined by the rule. Output f of x is dependent on the value of the independent input variable.
Correct.
All possible inputs are the domain of the function, and the set of outputs is the range of the function.
Perfect. For example, if I have defined a function and I have defined it with this rule, the rule is f of x equals to 2x plus 1. Now, if I input minus 1 times 2 is minus 2, adding 1 will give me minus 1. Do you see that? So, corresponding to the input of minus 1, I get an output of minus 1. If I put 0 as the input, output is going to be 1. For 1 as an input, output is 3. And for 2, the output is 5. You see that relation, correct?
Yeah.
So that is how we can put it. We can also show this as an input-output table, basically. Rule in between transforms those inputs into the correct outputs. You get the idea. And clearly, this is a linear function 1 to 1, whose reverse process, if I now go from output, let us say from 5, I know if I go reverse, in that case, I know I should be getting 2 since it is a linear function, correct?
Yeah.
Okay. Now, since we're talking about inverse function, let's see, we'll skip this part. Okay. Okay. Let's go to inverse function, right? So let me get to this and explain you one more concept, since now our focus will be more on inverse function. Is that okay?
Yeah.
So we have actually introduced to you the function which we are saying inverse function. And I'm also talking to you about reverse operation. Is that okay?
Yeah.
Now, that is a very critical thing. I've also said in between that if the function has the coordinate point x and y, in that case, the reverse will be y and x, correct? That becomes the inverse, correct? If this is f of x, right? If this is f of x, then this is, we denote inverse function like this, minus 1 on the top. Do you see? Inverse of f of x is written as shown there. Is that clear to you? We swap x and y. Is that clear?
Yeah.
Now, going with the same example, we have f of x equals to 2x plus 1, right? Now, let us see, how do we find inverse of this function? So, inverse, let me first explain you, how do we find inverse? Can you read this equation? What is the output equals to? Times
What do you mean?
plus 1, right?
Yeah.
Times 2 plus 1, correct? That is the function, correct? Now, let us see what is the reverse operation. Can you reverse the operation?
Yeah. Divide by 2 and minus 1.
We'll start from here. Take away 2, subtract 2. and then divide by 2. Do you see that? Subtract 2 and then divide by 2. Do you see? We went in the reverse operation. Then you get the inverse. And then what you get is the inverse of the function. You get the idea.
Yeah.
So now the function will be this. So inverse function, I could write y as divide by 2. That means subtract 1 and then divide by 2. Is that clear to you?
Yeah.
This is the inverse of the function. So that is f inverse. Is that okay? Now let me show you the same inverse function mathematically. This was done by words. So easy. You see that?
Yeah.
So easy. Now let me show you algebraically. So algebraically, how we do it? Now we'll do algebraic solution. First step is swap. We have the equation y equals to 2x plus 1, correct?
Yes.
So we write this as x is equals to 2y plus 1. So first step is swap.
Okay.
Because inverse is going the backward, reverse, right? Output is becoming input, input is becoming output. So the independent variable now, which was y, becomes x, correct?
Yeah.
Range becomes domain, domain becomes range. You see all that?
Yeah.
Now, I have to now isolate y. Because basically, we swap and then we really want to put that independent variable along x and y along the vertical axis. So how will you do? You bring 1 here, right? X minus 1 is 2y. And what is y equals to? You will divide by 2, correct?
Yeah.
You see, you got exactly the same relation.
Yeah.
Algebraically and with words, exactly same thing. This is exactly the reverse operation. You understand? You do an operation and then flip it. You take a candy and wrap it, and then you unwrap it and get the candy back. Then it is an inverse function.
Yeah.
You get the idea, correct?
Yeah.
That is what it is, practically. And very easily we could do the inverse. And now, see, if I have this y equals to, and let's check with our values. We earlier said if the input is 2, output is 5, correct? Now, I can put, now I want to find y, which is x minus 1 over 2. So instead of 2, I'm putting input as 5. If I put 5 here, what do I get? 5 minus 1 over 2 is what? 4 over 2, which is 2. Do you see that? You got the value back?
Yeah.
That is what the inverse function is. Is this concept clear to you?
Yeah.
Can you explain me this concept?
Yeah. So basically, the inverse is you put in an input, and when you get an output, that's the function. But the inverse of it is when you reverse the equation. So you put in the output and you get the input back, and that's the inverse.
Very good. And this you could do in many different ways. One way is just by words. In words, we can explain the reverse operation, right? For example, you say, my way to go to the school is, I go 2 blocks north and 3 blocks east, correct? Yeah. So what will be your return journey? You will go 3 blocks west and 2 south. You will do the reverse operation to come back to your home. You get the idea? This is inverse function. We do it in daily life. You get the idea, right?
Yeah.
So that is what inverse function is. Nothing great. It is a simple operation, returning back. Remember the path you followed and then just follow it backwards. You will reach the same place if it is a function, correct?
Yeah.
If on the path there are ambiguities, 2 different roads, and you don't know which one to decide now, then it's a problem, correct?
Yeah.
Or if the path is not well defined. One is going up, both are going south, but we don't know whether to go above the flyover or below the flyover. We don't know. Then it is inverse is not a function. You get the idea, correct?
Yeah.
Perfect. So, and there are many other ways. One more way is doing graphical. So let us now look into graph solution, right? So I'm just skipping few slides here. Okay, this one. So here, initially I told you that the quadratic function represents a parabola, right? And its inverse is not a function. because it fails horizontal line test, right?
Yeah.
Okay. So now what we have done here is that in this operation, inverse function, can you please read what is written here?
Inverse function. Undo the function operation or reverse the operation.
Correct.
Find the value of x for which f of x equals 10.
Yes. And this is the question. We have our function, which is f of x is square root of x plus 1. I know you have not done square root, but I have a graph for this function. F of x is square root of x plus 1. This is my f of x. Is that okay?
Yeah.
So square root function, you understand, right? If I write 4, square root of 4 is 2, right? Square root of
Yeah.
9 is 3. Now here it
Yeah.
is x plus 1. So you know the transformation. You have moved the graph 1 unit left, correct? So
Yeah.
this is graph 1 unit left. So square root x translated 1 unit left. Is that clear to you?
Yeah.
Is our f of x. Is that clear? Now, the idea here is to find the inverse of this function, right? Now, one thing very clear. If you look at this function, which is f of x, can you tell me the domain and range of f of x?
Negative, the domain is negative infinity, infinity.
Correct. So we can write x is greater than equal to minus 1, correct?
Yeah.
And what is the range?
0 infinity.
0 to, yes, greater than 0. Greater than equal to 0. That's the range. Now, when I flip this, make it inverse, then what is going to be my domain? Tell me.
Negative 1 is greater than or equal to x.
That will be range. Because now domain becomes the range. Do you see that?
Oh, yeah.
Domain becomes range, range becomes domain. You see that?
Yeah.
So that is one way. I have written the inverse function right there, right? So what we are comparing now is the function and the inverse of the function. I'll teach you how do we get this inverse verbally, and then we will also see how do we get this inverse algebraically, and also how do we get it by graph. Is it okay? So I'm going to teach you 3 different ways of finding inverse, right? How to find inverse. So one is words, which I love. Very simple. 2, algebra. Solving an equation. 3rd, graph. Okay. Now words. We have this function f of x is equal to square root of x plus 1. So what is the reverse operation? Tell me. Square root. We are saying square root. So how will you operate this function? Like if I have I have to find square root. Let us say x is let me take x as 8. Is that okay? Then how will you find the answer? You will say, well, 8 plus 1 square. So how will you define this? You add 1 to the 8. Number is 8, right?
Yeah.
So add 1, then square root. That is the operation. You'll get y value, right?
Yeah.
That gives you the function. Is that clear? Now the reverse operation will be u square. Correct? You're going here and then subtract 1. Is that clear to you? Reverse operation. So we call this f inverse of x, which is square x and subtract 1. You get the idea. How we got it by words? Easy.
Yeah.
If you have confusion, take a number and see how we did it. Take a number 8, 8 plus 1 square root. How will you calculate? Add 1 to 8, then you find the square. This is what I wrote. Add 1 square root of. You get your function. You get the idea.
Yeah.
So that is how from input we get the output. So when I have to do the reverse operation, I will start with subtracting 1 now and then finding the square of that number to give me the original number. Simple?
Yeah.
So we are done by words. Algebra. Just swap x and y. So let me show you with algebra, right? So we're talking about y, let me use a different ink. Okay. So we'll write function with green, right? So y equals to square root of x plus 1 algebra. Step number 1, you have to do swap x and y, correct?
Yeah.
So we write x equals to square root of y plus 1. So isolate y. So square both sides, of course.
Yeah.
Y plus 1. And then isolate x square minus 1 equals to y. Now write down f inverse of x is x square minus 1. Get the same answer, correct?
Yeah.
Is that simple, easy to understand?
Yeah.
Perfect. Third method, using a graph. So what are we actually doing? We are swapping x and y, right? So using a graph is the easiest way to do it. If I have x, y, and if I do this transformation, changing y to x, basically what are we doing? You understand? How do we get this xy flipped to yx? Only if we reflect the graph on the line which is diagonal, which is y equals to x. So if you flip the graph on a diagonal line y equals to x, then you get the inverse. Automatically, all xy becomes yx, all xy becomes yx, correct?
Yeah.
That is the transformation. So that is what we do. So if you have to find inverse of a function graphically, then sketch the line y equals to x and then flip mirror image on that particular line gives you the inverse, correct?
Yeah.
If you are given the coordinate points, just flip the coordinate points in the set. If I write 2, 3, just write 3, 2, correct? You will get the inverse, correct?
Yeah.
And you will notice one thing. If the point is 5, 5, then the inverse will be same point, correct?
Yeah.
Because when you flip 5, 5, you get 5, 5. So what we notice here is that if you have a point A, A, both x, y values same, x equals to y, it is on this diagonal line, then inverse is going to be the same point, right? For that particular point, correct?
Yeah, but for the inverse, how do you get like the graph for it? You get the points, but how do you get the graph? Like how do you get the equation?
Okay, I'll show you here itself. So if you see the red graph, one of the points here is minus 1, 0, right?
Yeah.
This point is minus 1, 0. So when you flip, what do you get?
0 minus 1.
0 minus 1. Do you see that?
Yeah.
So basically it is reflected, right? So you diagonally move on this line and same number, mirror image, you get that point. Do you see that?
Yeah.
That is how you get it on the graph. And then this point is like AA, both same. X. So the intersection of the graph with the diagonal line y equals to x will give us invariant points. These are called invariant points. They will not change. They will remain same in both function and its inverse. Is that clear to you?
Yeah.
So take up any point. Y-intercept and x-intercepts are good points to take. Now what is this point? This point is 0, 1, right?
Yeah.
0, 1. When I flip 0, 1, I get 1, 0. There you go. Do you see how the green graph comes from the red graph as a reflection on the line y equals to x, correct? And now, of course, we have the invariant point. We know the nature of the graph going towards infinity in a direction shown. Is that clear to you?
Yeah.
Have a good look at it and then see. Perfect. So you notice a couple of things here. One is the domain becomes the range for the inverse function. Range becomes the domain for the inverse function. There are some points which are common to both functions, which are called invariant points, right? Only functions who will pass the horizontal line test will have inverse as a function. If horizontal line test fails, then we can restrict the domain of the function to make its inverse as a function, correct?
Yeah.
We also learned many techniques to find the inverse of a function. One of them is using the words, do the reverse operation, correct? It is like wrapping and unwrapping the candy. You get your result. That's so simple? Is that clear to you?
Yeah.
We could do algebraically by swapping x and y values and then isolating y. we get the inverse. Or we could reflect the graph on the line y equals to x as shown here and get the inverse. Is that clear to you?
Yeah.
Perfect. So we'll move from here. Here is your parabola. Correct. So we'll now look into this particular function, f of x equals to x squared. So the parent quadratic function, correct?
Yeah.
Clearly, since it does not pass the horizontal line test, its inverse is not a function, correct?
Yeah.
So if I flip it on the line y equals to x, what do I get? I get a parabola which is opening right? So this is opens right. Is that okay?
Yeah.
Which is not a function, since now we can clearly see a vertical line crosses at 2 points. So it is not a function. However, if I restrict the domain, then I can make it a function, correct?
Yeah.
So going backwards, the function is f of x is x squared, square of a number, inverse, correct? Square root of the number is the reverse operation. Whenever you do square root, you do plus and minus also. So
Yeah.
the inverse is plus and minus square root x. Since for many values of x, in fact all except 0, we will get two different values for y, and therefore it is not a function. What you notice is that the domain, which is all real numbers, now becomes the range, right? Range
Yeah.
is all real numbers for the inverse. It goes from minus infinity to plus infinity. However, the range which was greater than or equal to 0 becomes the domain. Within square root function we can have only non-negative numbers, correct?
Yeah.
So that is how we are going to find inverse of quadratic relations, right? We'll look into strategies, exactly how to do it with different examples later. But for now, this much is clear to you, right?
Yeah.
Okay. So let me move from here to a few concrete examples. So I'll stop sharing this, but I'll do those examples at random on a whiteboard. Is that okay? We'll just figure it out.
Okay.
Yeah. Okay. So we know how to do x squared. Let me write down some functions here. We'll focus on lines and parabolas. So if I have a function y equals to half x plus 2, can you find the inverse of this function? Tell me. By words.
The inverse of the function is 2 times x minus 2.
No. Read. If I put input as, let us say, 8, so how will you calculate this answer? First thing, what will you do? Half, right? Divide, you say divide, let me write some. Divide by 2, right? And then you say add 2. Is that okay?
Yeah.
So if I do inverse, what will I have to do?
Oh, multiply by 2 and subtract
minus
2.
2. You're going in
Oh.
this direction. So get used to
Oh.
reading from the right side. Is that okay? And
Yeah.
then times 2. Do you understand? So we do
Yeah.
x minus 2 and then multiply by 2. That is the y value. This is the inverse function. You see that?
Yeah.
So we'll write this as f inverse of x. It is a function of x. 2 times x minus 2. Does it make sense to you?
Yeah.
One more example we'll do. Okay, clear?
Yeah.
So again, I'm writing y equals to 3x minus half. Now, how will you do the inverse? Tell me straight. F inverse x is how much?
1
First
third.
add half. First add half. Go
Yeah.
from here. Go from here, right?
Add half and divide by 3.
Correct. Divide by 3. You get the idea?
Yeah.
You can simplify, but this is what it is. You get the idea.
Yeah.
Perfect. So we have seen by words, how do we do it? Algebraically is very simple. So I'm not getting there, okay? Well, all are simple for you now, correct? Let me just, okay, let's take algebraically. So y equals to x plus 3 over 2. Algebraically, how are we going to do it? So swap, right? So we'll have x equals to y plus 3 over 2, cross multiply, 2x equals to y plus 3, and 2x minus 3 equals to y, correct? So we write there f inverse of x is 2x minus 3. Is that clear to you?
Yeah.
By words also, you can verify. This is how you'll get. How will you verify? Take an input, right? Do you understand? So if I take x as, let us say, 5, right? Then what do you do first? You do 5 plus 3 and then divide by 2. Do your operation, right? First you do
Yeah.
plus 3, right? And then you divide by 2, correct? So
Yeah.
the reverse operation is multiply by 2 and then take 3. Do you see that? Multiply by 2 and then take 3. So easy. Practice. You will get it. Beautiful. Okay? You think this word will not work for parabola? I will show you just now how it works very easily with parabola. Okay? Let me clear the screen. Before going there, let me take a graph and then complete this linear function. Let's say I've drawn a line here. This is my line, correct? Can you find the inverse of this function? Let us say this point here is 5 and this point here is 6. Can you graph the line which is inverse of this? So first thing first, draw a line y equals to x, correct?
Yeah.
And for drawing a line, you need only 2 points, correct?
Yeah.
Let's take 3. 3 is good. 1 is this invariant point. Is that okay? Whichever y equals to x crosses, correct?
Yeah.
Then we have to swap this. 5, 0, 0, 5 becomes 5, 0, correct? So this point is going to come here.
Yeah.
And this point is going to go there, correct?
Yeah.
Reflect. So line joining these 3 points will be my inverse. Do you see that?
Yeah.
So if this is the function f of x, this is my inverse of the function. Is this clear to you?
Yeah.
Very easy. If I have a horizontal line, then the inverse will be going through this point and it will be vertical. Do you see that? Oops.
Yeah.
Is that clear to you?
Yeah.
Correct? Well, vertical line is not a function, but always you don't get a function, right? We have inverse relation, correct? So for this, I will not write f inverse. Do you see that? I will not write f inverse. Now this is not a function. I will not write like this. So you have to be careful. You can only use this nomenclature if the inverse is a function. Now you will say inverse relation. You understand?
Yeah.
So vertical line is not a function. So I cannot write f inverse x as I did it earlier for all other lines. Perfect?
Yeah.
Now, let's take parabola. So you saw it with the graph, how simple it was, right? Let me just sketch it once again. Let's say we have this parabola, right? And since we have a parabola and we have to just reflect it on a line which is y equals to x, then practically, what am I going to do? I know this is not accurate, but it gives you fairly good idea, right? Mark the invariant points. They are not going to change, right?
Yeah.
Then you know this value. So this value is, so this line is not y equals to x is not so good. Right? Let me just go back, remove this line and draw a proper line. Is that okay? So that I give you fairly good idea of how the graph should really look like. Okay, so let me draw a diagonal line, a better one. Correct. This is even better, right? Okay.
Yeah.
So mark the invariant points, which are these for you. And then look at the intercepts. So we have this particular intercepts, for example, right? This is, let us say, 0, 1, right? So when you do this point here, it will go somewhere there, correct?
Yeah.
Similarly, this intercepts will you go like this somewhere here, right?
Yeah.
So, and similarly, this point will go somewhere there, correct?
Yeah.
And then we already have this point. Do you see we have got a graph and we could say sketch this function here. Do you see this?
Yeah.
And that is how you'll sketch the inverse of the function. You can take more points and get more accurate graph. On a graph paper, it is very easy to move diagonal, right?
Yeah.
Perfect. So this way. Now, let me give you a very difficult question. We have y equals to 2 times x minus 3 whole square plus 5. How will I find inverse of this relation? Tell me by words. How will you do this? If I take x as equal to, let us say 1, then I will do 2 times 1 minus 3. It is good to check. Do you understand? So that you understand exactly the order of operation. You understand? So if I put 1 here, actually what I do, I first add these up, right? Add or subtract. So minus 3 I'm doing, right? So from x, I do minus 3. And then what I do? I square it, right?
Yeah.
I mean, I square it. Okay. And then what I do? I times it by 2, correct? And then what I do? I subtract 5. Is that clear to you?
Yeah.
What is the reverse operation? If I have x, I will add 5, correct? We are starting from here. And then divide by 2, correct?
Yeah.
Square root, right?
Yeah.
And plus 3. And whenever you square root, you have to do plus and minus. You got your result.
Yeah.
Do you see that? Without algebraic calculation, without drawing a graph. For drawing a graph, you need table of values, correct?
Yeah.
Or vertex and steps, and you have learned so many ways of doing it, correct? But see, with words, if you are clear in your mind, what is the reverse operation? You can do these questions in seconds, just as I'm trying to show you. And students normally are not able to do this simple operation. I'm not joking. I've been teaching many students. But if you practice and see how the operation is performed, oops, what happened? Okay. How the operation is performed by taking an example, then you are clear. You did first what? Take away 3, square the number, multiply by 2, take away 5. It was plus 5. I'm sorry. It should have been plus 5. So I do this minus 5. Is that clear to you?
Yeah.
No, reverse. So if it was plus 5, just do 5 minus, multiply means divide, square means square root. Whenever you put square root, you have to write plus and minus, and then plus 3. Okay? Now, important thing here, look at this point. You know inverse is not a function, but I want to make this inverse as a function. How can I do it? Can you tell me? I have to restrict the domain.
Yeah.
How can you restrict domain? Your vertex is at 3, right? 3, 5. So you say x greater than equal to 3. Do you see that? In that case, we will only have a positive sign. So I can write this as 3 plus square root of x minus 5 over 2. Now that becomes inverse function. And now I can write this as f inverse x. Does it make sense to you?
Yeah.
Do you see how easily we have done it?
Yeah.
Let's take another example and try to do this. Now you realize if the graph is given to you, it is not bad. But if you have to use a graph of your own, it is very difficult, right? So let me just write half x plus 3 whole square minus 7. Let us see. If I have to do it algebraically, how will I do it? First thing is swap x and y, correct? X equals to half y plus 3 whole square minus 7. Now isolate y. So we'll do x minus 7 equals to half y plus 3 whole square multiply by 2. So we get 2 times x minus 7 equals to y plus 3 whole square. Now do square root. So whenever you do square root, you write plus
It should be x plus 7, right?
Pardon?
Should it be x plus 7 because you're adding?
Yeah, plus 7, plus 7. Yeah, minus becomes plus. Correct. So x plus 7, and now we are 2 times. You're right. Thank you. Square root it, and whenever you do square root, do plus and minus, and now we got y plus 3 equals to this, and so we'll continue, and we can now write this as y equals to minus 3 plus minus square root 2 times x plus 7. Is that clear to you?
Yeah.
Not a function. So what we do is we could restrict the domain. Restrict domain as x. Let us say less than equal to minus 3 this time. So when I'm doing this parabola less than equal to, I'm looking into the negative x values, correct?
Yeah.
Remember, domain and range has to be swapped. And therefore, I will take negative sign here and write minus square root 2x plus 7. Is that okay?
Yeah.
You understand the process now. Perfect. We are not talking about when we restricted the function. We're talking about a graph, which is this graph now restricted, means we are talking about this side of the parabola, right?
Yeah.
And therefore, the inverse will be actually that this side of the parabola going downwards, not the upwards. And that is how we could get it using minus instead of plus minus, because the domain has been restricted. Is that clear to you?
Yeah.
Perfect. So here we can actually end our class. Let me clear the screen, and you can now summarize what have we learned in today's lesson. Can you please summarize our learnings about inverse functions?
So basically, first we started learning about what like relations and functions are and how that works. Then we got more into like how to find the inverse of a function. Like there's three methods algebraically. You can graph it, or you can use words and your own words to explain it. I think words is the simplest because you could do it really quickly. And then you can basically find the inverse of a function and like see if it's a real function or not. And if you want to, if something isn't a real function and you want to make it a real function, you can restrict it.
Correct. Good job. Perfect. So with that, we'll end our class. I'll share some more videos with you so that you could practice questions based on inverse functions, right? So I'll send you after the class, try those questions, and then we'll move forward from here. Is that clear to you?
Yeah.
On my YouTube channel also, can you just go to their YouTube and just search Anil Kumar? Go to YouTube.
Okay.
You can share the screen. I'll tell you which
Okay.
playlist to look into, okay? That'll be good for you.
Okay.
And you can do it anytime. I've got hundreds of videos on these topics, correct? We know 20,000 plus videos free for all students on my YouTube channel. So just type Anil Kumar,
Okay.
inverse functions playlist. See what you get. Okay, so inverse function, click this 128 video set. Okay, so the very first video gives you in details. Click the very first video, inverse function. I'm going to explain you all the concepts in this video, and there are following so many different test questions. So the other questions which you see 128 in this particular video, they are the test questions. You understand?
Yeah.
Okay. Again, click the same thing and you look into another playlist. Just search another playlist. Here I'm trying to explain you what I did in today's lesson in a different way. Okay, you'll love it. Okay, search again. Yeah, we'll look into more videos. Okay, go down. So individual videos also you can see, and this is the lesson with special methods to find inverse, which we did just now today, right? Exactly the same questions which we did. I earlier did with many other students. These students are from different countries. Okay, so that is what we did today. This is exact review of what we did, kind of, because our approach was slightly different since we were restricting ourselves to linear and quadratic functions. But anyway, now you have a way to go back and look into videos. Now from these videos, my suggestion, Abhinav, is when you look at the video, there will be a question. Stop the video there and then. Answer the question yourself and then check your solution with the video. Is it okay?
Yeah.
You might learn few new interesting things in the video itself, correct?
Yeah.
So as an exercise for your homework, you could do about 20 videos, 20 questions on inverse functions. That'll be good. And then we'll continue from here. Okay?
Okay.
Okay, great. Thank you.
Bye.
Bye. All the best.